Okay. So we'll look at domain first, then we'll look at range, and that'll be that. Okay, and hopefully we'll get you some time to get started on your assignment today. I hope so. Okay. So, that being said, okay, let's kind of go through the ideas of what domain and range are. Okay, so the domain, okay, are all the possible input, or inputs, I guess. In other words, x values normally, right? Doesn't always have to be x values, right? Could be t values, could be other stuff, you know, but all the possible inputs of a function. Okay, unless, oops, otherwise defined. Okay, so sometimes, right, we're given a function, we're saying, we're told, here's the domain for this function. Or maybe we're limited, you know, in that domain kind of thing. So sometimes the domain is something that's given to us, all right? Other times, we're just given a function, asked to identify its domain, and the idea there then is to describe just all of the possible, you know, input or x values or t values, you know, whatever your independent variable is, all the possible values for those independent variables. That would be like okay in the function. Okay. So, when we talk about domain, it's kind of hard to like imagine trying to talk about every value that works, right? Even though with our definition here, it's just all the things that kind of like work, all the inputs that kind of like work in the function and stuff like that. But it'd be a long list of things to go through, right? An infinite list. So rather than starting with like a single thing and checking to see yes it works or yes it, or no it does not work, all right, what we do instead is we assume everything works, okay, and then we try to look for things that will not work, right? Instead of like going part by part and saying this one will work in the function, this one will not work in the function, we just assume everything works and then look for things that we won't want to include in the domain. And those things are known as, right, domain restrictions. Okay, and there are two main styles, two flavors, two kinds of domain restriction that we're going to be keeping an eye out for. All right, one, well, what's one of the big no-nos in math? We never want to divide by what? Zero, right? And so if we were to ever come across an x value that would cause us to divide by 0, we want to restrict that value from our domain, okay? We've seen it show up already when we were talking about like the difference quotient, right? In the difference quotient, f of x plus h minus f of x all over h, right? There was a little stipulation there, h cannot be 0 because, again, we don't divide by 0. Okay? Number 2, we also don't want to take the square root of what? Of a negative number, right? Because that would make the value what? Imaginary, right? Okay. So the square root. Now, is it only square roots that's true for? What about cube roots? Can we take the cube root of a negative? Yes. Can we take the fourth root of a negative? No. Okay. So square roots and even powered root. Okay. So square root and the even powered root of a negative. Okay, we're going to be keeping it real for now. Alright, so those are the two things we're going to look for, right? If neither of these two kind of behaviors show up in your function, then we can assume that the function has a domain of all real numbers. All real numbers, unless otherwise, again, specified. So let's take an example here. Alright, so the question is, what is the domain of each function? What is the domain of each function? All right, so we'll start with this first one here. We'll say g of x is equal to 4x squared minus 3x minus 7. 4x squared minus 3x minus 7. With this function, is it possible for us to divide by 0? Is there a denominator in this problem at all? Not really. I mean, we could say, well, Mr. Wood, you could put it like all over 1, and like, yeah, okay, that would still be the same thing. But, excuse me, there's no x in a denominator, right? And so it's impossible for us to divide by 0. Okay. Could we possibly take the square? Is there a square root, or is there an even powered root in this problem? No, right? We're going to take our x value and square it, but that's not a square root. That's just squaring something, right? And we're going to then take another x and just raise it to the first power there. So, again, no even powered roots. And again, this is not necessary for you guys to write out when you're doing your work, okay? I'm just doing this for the notes, just so that way you can have that to like refer to it, kind of like the thinking as well. But anyway, so then what would our domain be here? All real numbers, right? Negative infinity to infinity, yeah, okay? And again, since I don't specify what method we're going to use to describe the domain, you are free to do it however you would like. So for example, you could literally write the sentence out, all real numbers. Or not the sentence, the phrase, I guess. The domain is all real numbers. That's fine, say that phrase. You could also write it in interval notation, right? Negative infinity to infinity, right? We put the round parentheses because we don't include infinity there in that. Okay. Or, of course, you could use the inequality as well. Always make sure, in either an inequality or an interval, I guess it's not so important for an inequality, but for an interval for sure, you always want your lower number to the left, your higher number on the right there, kind of thing. Okay. But that's it. Okay. All right, let's try another one here. I don't need to write that again. Let's do number 2. Let's say f of x equals 1 over the quantity x plus 5. Okay. Could we divide by 0 in this case? Yes. Okay. What x value would create that scenario? Yeah, negative 5. Exactly right. Okay. So now let me just kind of help ourselves out. So here, okay, we could divide by 0. So we set the denominator equal to 0. We set the denominator equal to the very thing we don't want it to be, so that way we can find the x value that we don't want to use, right, that we want to exclude, okay, and solve for our variable. Okay, again, I'm just writing this out very explicitly just to make sure you guys have something to refer to or whatever. I guess you could always just go back and watch these videos too. It'd be the same thing. So anyway, and this is what you guys all kind of did mentally, I'm guessing. Something to this effect, at least. Okay. And so x equals negative 5 would make us have a 0 in the denominator, which would then make us undefined. And so then we'll write this in interval. I'll write the domain here in interval notation. So we only want to exclude a single number, negative 5. So we're still going to start with that, or the regular domain of negative infinity to infinity, and we want to remove negative 5 from that interval. So we'll still start at negative infinity. Okay. But we're not going to get up to infinity yet because we have to, then we hit our problem here at negative 5. Okay. And what kind of grouping symbol are we going to use here at the negative 5? Is it going to be a square bracket, or is it going to be a parenthesis? A parenthesis, right, where we don't want to include that negative 5, so we have to exclude it. Okay, I like to put the little u here. I think you really should do that to be official. I don't think, I guess I would probably still give you credit if you didn't, but you really should put a little union there. Okay, then where are we going to start our next interval? At what? Negative 5 again. Okay? The idea here is that we're going to go all the way up to -5, but not include it. And then we'll start right back at -5, not including it, and then on towards infinity. So that is how you exclude a single value. Okay? You exclude the -5 for this right interval, and then exclude the -5 for the left on the other interval there. Okay, for inequalities, if you want to do an inequality here, okay, you could say something like x is less than -5 or x is greater than -5, like that. Or you can do two compound inequalities, yeah.
When do you decide between the or and symbol?
You're saying for this?
For interval notation.
For interval notation, how about what symbol to use here?
Yeah.
So we'll only really be using the union symbol. So you're talking about like whether to use like this or the other, like the intersection symbol, you mean, which is like the yeah. So you're saying like this versus this.
Yeah.
So we'll only really be using this. We won't be using this too much. Actually, I don't think we'll be using it at all. Yeah, we don't have to worry about that. Okay, we're just gonna be joining up intervals and stuff like that. So, yes. So how do you know that dividing by, like, how do you know, sorry, repeat your question again, I'm not sure I understood.
How do you know if, like, we can divide by 0 or if we can't divide by 0?
So I don't think there's going to be any scenarios where we do divide by 0.
I know, but, like, in number 2 it says, like, here we could divide by 0.
Right, the idea is that, like, there is a potential for us to divide by 0. That x value, that would cause that, we need to make sure we remove that from the domain. That was kind of like the gist of what I was trying to say there. And maybe I didn't do it very clearly, but that was the gist of it. Okay? So yeah, there's that. Okay? Any other questions on that before we move on here? Pretty straightforward stuff, right? So I do want to talk here just briefly, and maybe you don't care, but I mean I'm going to go for it anyway. Dividing by 0. The reason why we want to avoid that here is because dividing by 0, well, I'm going to show you kind of what happens here, right? So let's say we take our little 1 over x plus 5, okay? And let's say, right, we know if we plug in -5, right? If I plug straight up, just plug in -5 here, it's going to add with the 5, make 0, all right? I'm going to get something that we don't know what to do. We don't know what 1 over 0 is, right? So if I just straight up did 1 over -5 plus 5, that would be equal to 1 over 0, and it's like, what does that even mean, right? Dividing something by 0. But what we can do, right, is we can kind of like see what happens as we approach -5. So for example, -4 is pretty close to -5, and so let's see what value we get when we just do -4, which is like that x value is close to -5 there. Okay, well, -4 plus 5 is 1, and so we get 1 over 1, which is equal to 1, okay? So no problems there. But let's get even closer to -5. Closer than -4 would be something like, maybe -4.9, okay? This was -1 away from -5. Now we're only -1/10 away. We'll add that to 5, okay? Which is 1 over -4.9 plus 5 is 0.1, which is 1 over 1/10, right? But what is 1 over 1/10? What does that equal? 10, right? Dividing by 1/10 is the same thing as multiplying by 10. Let's get even closer still. Let's do -4.99, right? That's even closer to -5, right? Again, we're trying to see what -5 would give us here when we add that with 5 and divide by, 1 by, divided by that. So we're getting closer here. We're now only 1/100th away. If we add 5 to that, we'll have 1 over 0.01, which is 1 over 1/100th, which means this is going to equal what? 100. Okay? And we'll stop after this one, because I think you're going to get it. Okay? Let's get even closer. 1/1000th away. So 0.001. That'd be 1 over 1/1000th, which then this is going to equal what? 1,000. So as we get closer and closer and closer to -5, as our x value gets closer and closer and closer to -5, what is our function or y value? What does it look like it's approaching? Infinity. Right. And so should we ever actually reach -5, then this value here would be approaching infinity, right? And it wouldn't have a value, okay, in that sense. I mean, infinity kind of has a value to it, but it kind of doesn't. It's a different kind of number than, you know, other numbers. We can still kind of like do math with it, but not in the same sense there. Okay? And so we would say then this does not exist. All right? It goes off infinitely without bound. And so that's why we don't want to divide by 0. We end up really going off towards infinity. Okay? So that's kind of like the idea there. Okay? This process right here, this is the process of, or this is kind of like a way to show the idea of taking a limit, which is a concept that we'll be looking at a little bit later in this class, and something that is fundamental to calculus too. Okay, so there's a little like pre-calculus kind of taste there. Not that you're going to be sitting at your desk and like doing like a million of these kind of problems where you like slowly approach, you know, like whatever the value is or something like that. You'll have your calculator to help you with that in some cases, and we'll get shortcuts and other things too. But anyway, this is just like this process is like called, you know, taking a limit. In this case, we're approaching -5 from the right-hand side. So, but anyway, you'll see more of that later. Okay. All right. So let's do one more here together, and then I'll have you guys try one on your own. Okay. So this is number 3, I guess. Same directions, right? We're going to find the domain of this function. Okay, so could we divide by 0 here?
Yes.
Is there an x in a denominator or anything like that? No, right? There's no x in the denominator, so we don't have to worry about dividing by 0. Could we take the square root of a negative or the even powered root of a negative? Yes, that is possible here. Okay, so let me show you here. Since we could have an imaginary result, I guess I'll say. Oops, I really should have called this. I'll call this h of x there. Okay. Since we could have had an imaginary result, all right, take what is under the root and set it to be. Okay. And so if we don't want to take the square root of a negative, we want to take this x minus 4, and what inequality symbol do we want to use here? We want to make sure that it's not negative. So what is not negative? How do you represent not negative using inequalities? Inequality symbols. So like greater than, less than, greater than, equal to, less than, equal to. What can we use here to guarantee something's not negative? Greater than or equal to what number? 0. Okay, yeah, we want something to be greater than or equal to 0, okay, right? That means not negative, right? If something's not negative, it either has to be 0 or positive. So we'll set that x minus 4 to be greater than or equal to 0, okay? Greater than or equal to 0, and solve. Okay? So in other words, x minus 4 is greater than or equal to 0, which means x has to be greater than or equal to 4. Okay, x has to be greater than or equal to 4. So like there's your domain right there. You could stop and just say there's my domain, right? Because that's describing all the possible x values if you want to use inequality. Okay? If you want to use interval notation, where is our interval going to start? Does it start at negative infinity? No, right? Because the lowest possible value could be here is 4. So we're going to start our interval at 4. Anything less than 4 will make our square root there, well, we take the square root of a negative. Okay. Since we're going to start at 4, what kind of grouping symbol should I put here? Bracket or parenthesis? Ooh. We want to include the 4. It's okay for it to be 4, right? 4 minus 4 is 0. The square root of 0 is 0, so that's okay. So we can include the 4. And then we'll go to what? Yeah, to infinity. Okay, so there's that. EC. All right, so here's one for y'all to try. All right, well, actually, this is for you to try. So try square root of 2x plus 6 over 3x minus 7. Okay, and I'll call this f of x again. Okay. What is the domain of f? So again, here consider your two domain restrictions. Could we possibly take the square root of a negative? Could we possibly divide by 0? Okay, and consider those in your analysis there of the domain. I want one domain for the whole thing, so please don't give me like two different domains there. Okay, put it all together in a single description of the domain. Please. I'll come around how the other functions are. I'm not sure about something. Nope, that's right. You do want to exclude that, but now be careful here. 0, right? If you plug 0 in here, it would be 2 times 0 plus 6, so it's going to be a positive 6. You're taking the square root, so that's okay, right? You can include the 0, that's fine. But like even if you do like negative 1, negative 1 times 2 will be negative 2 plus 6 is going to be 4. You can take the square root of 4, no problem. So you can, like, what I'm trying to show you is you can go further below that 0. So if you remember up here, with this square root, right, we didn't want it to be negative, so we couple this inside and set it to be greater than or equal to 0. That means that same principle right here. We don't want 2x plus 6 to be negative, so set it to be greater than or equal to 0, and solve from there. Okay, good. You've got your pieces there, but now can you put them all together in a single interval?
No.
My recommendation, start from the left, you know, on the number line, so to speak, right? So you can't start at negative infinity, right? Because you have to, right, you have to be, so is that your lowest point? And then you continue, so start your interval from there, and then move forward towards, you know, as far to the right as you can. So, yeah. Cool. All right. Like 30 more seconds here. I have a few people that are going to finish up some of their ideas, and then we'll talk about the range. Volunteer. Want to share what they got? Anyone? Ali?
I got bracket.
Sorry. Okay, yes. Bracket.
Bracket -3.
-3.
And 7/3.
Up to 7/3, parentheses. Okay.
And the
Union.
and parentheses 7/3
To infinity. All right. Sounds good. All right, looks good to me. All right, so yes, Julie.
Just curious, how would you write it in the other way? Like, I got that answer, but I was just, how do you write it like the x is greater than...
With like inequalities and stuff like that. So what I suggest here is, since we're going to include the -3, well, you can again kind of like use your interval to guide you there. We're still going to have these on the left and the right here, but since we're going to include it, we'll put a less than or equal to x, and then just a less than for the 7/3. And we'll say or, and then we'll say 7/3 is less than x, or if you like, you can say x is greater than 7/3, one of those two, right? If you just flip it around kind of thing. So that would be how it would be for inequalities. Okay. Questions on any of that? Anyone need to see like where some of those pieces came from, or how do you put the pieces together? No questions? We're all good? Okay. So I gave you the hard one there, right? I put out, I showed you how to do square root by itself, I showed you how to do divide by 0 by itself, and then I threw all this together at once. So good job there putting it all together on that, okay? Because it's not basic, I guess, okay? So anyway, all right. Let's talk about range real quick. All right, range is a little bit tricky. These are all the possible outputs. Okay, or if you want to think, like y values, okay, or function values, okay, of a function. I guess it doesn't really have to be a function either. It could just be a relation, but for our purposes, I guess we're going to be working most with functions. Okay. Range is a little bit trickier because we don't really talk about, I mean, there are going to be such things as range restrictions and things, but we're not going to be necessarily solving for them, okay? We're going to use kind of like a combination of dot, dot, dot. Well, we're going to use a combination of those families of function graphs that we talked about from before, right? Using these shapes to kind of help us identify the ranges, okay, things we've already talked about, right? We know what a line looks like, right? So we know that, okay, if it's a line, then unless it's a horizontal line, right, our range is going to be all real numbers, right? If it's going to be an absolute value function, you know your range won't be all real numbers. It's going to be wherever the y-coordinate of the vertex is and then above it. Or if it's, if the absolute value function is pointing the other direction, then it'll be, from the vertex and then downward and stuff like that, okay? So we're going to be using kind of a combination of these families of functions and the transformations to help us then identify the range, okay? Or when all else fails, right, if we get something really complicated, then we'll just be using our calculators, believe it or not. Yeah, that will be part of it too, is just correctly, kind of using our calculators to identify stuff too. Okay? So, anyway, let's take a look at a function here real quick. So, for example, if we have just like y equals 2x minus 3, okay, and we want to know what the range of that is. Well, what is 2x minus 3? It is the graph of a what? Or its graph would be a what? A line, right? Okay. Would it be a horizontal line? No, right? A horizontal line is just when you have like y equals a number. Again, if it was a horizontal line, then your range would just be that number, okay? But since it's like a diagonal line, I guess we'll say, then the range is just going to be what? All real numbers, yeah, or negative infinity to infinity, exactly right. Yeah. So no surprises there. Again, that's just from us knowing what we know. Of course, yes, question.
So if you did have like a horizontal line and you wrote the range, would you just put that one number in brackets?
I'd say so, yeah. Or you could just, I guess you could just like literally say the range is just y equals the number. Like you could just literally say that, yeah. or I guess, yeah, I would say like square, like if it was like y equals 4, I would say you would probably want to do like square bracket 4, then 4 square bracket, you know, like 4 and 4, and then both square brackets kind of thing, if you wanted to do that. Okay, and again, just a really quick show you here, right, 2x minus 3 when we graph it. Okay, sure enough, it looks like it goes down towards negative infinity and up towards positive infinity there, so we cover all of our y values. Okay. How about y equals negative 2x squared plus 5x minus 7? Okay. What kind of shape are we going to have here? Okay, a parabola. So knowing it's going to be a parabola then, can we expect our range to be all real numbers? No, right? Okay, a parabola has either a lowest point or a highest point, a absolute minimum or an absolute maximum, right, kind of thing. Specifically for this one, what do we know about how the parabola is going to be shaping, or how is it going to be shaped? How's it going to be like facing or whatever? What can we say about it? So go ahead, Megan, what do you say?
It's going to be facing down.
Right, so, yep, exactly. We have that negative lead coefficient there, so we can expect our parabola is going to be downward facing. So that means we're going to have a range from negative infinity to some number. Okay? Now, if you know how to figure out that number on your own, great. We'll look at that later. But for right now, I'm going to show you how you can use your calculator to do it. Okay? Just because, again, this is something that you should be able to do. All right? So we'll type it into our calculator, negative 2x squared. And yeah, if you want to follow along, I'll give you a couple seconds here to type it in. Whoops. Okay. So I think you guys know how to graph, so I'll just go ahead and jump to the graph here, and I'll wait for you all to get a chance to type it in and stuff like that too. Okay. And it really is a good idea to, follow along with this. I mean, unless you if you're super confident about your calculator skills, you guys know what's best. But I'll say, it's just helpful for you guys to follow along with me, even if you think you know what you're doing, just because sometimes you run into troubles, and you all need to know how to troubleshoot your own calculators, right? And so if it comes to a test or a quiz, you can't be like, hey, Mr. Wig, can you show me how you did this thing on the calculator before? I'll be like, you should have asked back when we were in class and stuff like that. So please do take the opportunity here to use a calculator and become familiar with a piece of technology. All right. So anyway, there's our graph, right? We can see clearly we're going to keep going downwards here. And we're interested, right, in whatever this y value is. We're going to go from negative infinity up to then whatever this is. So what command can we use in our calculator to identify that y value that we want? Megan? Second trace.
And then 4.
Yes, in this situation, right, we want a maximum because the y value here is a maximum point of our graph. And so second trace, maximum. Okay, now, again, if you guys have never done this before, forgive me if you've done this before a million times, and this is like old hat for you, but for those of you who've never done this before, okay, it's going to ask for the left bound. So that means you want to use your arrows here, moving left and right. You want to make sure that you're to the left of that maximum. And you're going to hit enter. And now it's asking for the right bound. So you're going to move your cursor, your little target thing there. It'll stay on the curve. Move it to the right, to the right of that maximum and hit enter. And then guess. And then the idea of a guess is that you're supposed to kind of move the cursor in towards where the maximum is. So that way your calculator, just gets a better idea of where it is. And you hit enter one more time. And then boom. So the range for this graph, according to our calculator, is going to be from negative infinity to what value? Negative 3.875. But why didn't we use 1.25? Yeah, that's an x, right? We're trying to describe the range. There's all the possible y values. So we want to use the range there, okay? So use that negative 3.875. Okay. And you're like, man, that's kind of a nice decimal. I wonder what it is as a fraction. Well, I mean, if you want to, you can go back to your calculator, type it in your home screen, hit math, enter, enter, and it's negative 31/8. Okay, so if you want to use a fraction, improper fraction instead, there it is. Okay, question? Why wouldn't it be just negative 7? Because of so explain to me why you think it wouldn't just be negative 7.
Because there's just a minus 7 at the end.
It's like a transformation is what you're saying, right? Yeah, okay. So that's a great question. All right. We've talked about transformations, right, and how like it would take our parabola and shift it right a certain amount, shift it up or down a certain amount, right or left a certain amount, up or down a certain amount. Okay. The format, though, for those kinds of transformations, if you remember, it was transformations done to x squared. Okay. And so if we wanted to shift x squared up 7, it would be x squared plus 7. The negative 2 in front, that involves like a stretching or a shrinking vertically, and then the flip. It's this 5x that kind of throws things off. Okay? Now, we will be able to rewrite a quadratic equation that's in this form into a form that would then show that transformation that you're talking about, Jackson. But right now we're going to hold off on that. Okay? But yes, we can. It involves completing the square, which we all know how to do now, right? Love it. Okay? So you can complete the square here, and it would result in, you know, what we're trying to do. You know, it would result in that kind of thing. So, and I can show that to you later if we have time, or if you're interested still too. Okay? But good point. I'm glad you asked that. All right. So, any other questions on this? Okay. So, let me have you all try some, like 1 or 2 more here. Actually, you know what? I'm going to get you guys started on your assignment. How about that? We'll just let you do that, and then we can ask you guys can ask me questions if you get stuck on something on the assignment or something like that. Okay. So, here's what I've got for you. Okay, the assignment is on Google Classroom. There's a few problems from the book, and there is a worksheet that asks you to find domain and range. Except for the very last two, the last two on the worksheet ask you to just find the domain. You'll see in the directions there, but just, you know, don't do extra work if you don't need to, I guess, right? I also have assigned some TenMarks assignments to you, but they will not be due until Monday. Okay, they won't be due until Monday. So if you get done the homework and you want to get started on, you know, that, then that's fine. Okay, but these TenMarks are not like optional. I'd like you to do those. Okay, so everyone kind of thing. Okay, and then Zoe, I'll make sure I get you your login information since we haven't gotten you. Sorry, Zoe Star, I'll get you your login information there since you haven't had that yet. Yeah. Okay. So if you would please, since I gave you the time here, let's get you started. You know, please get started on that assignment. I'll come around and help you as necessary. If you think you get stuck on something, or you just want to check, you know, bounce an idea, or just make sure it's right. Yeah. So it's on the Google Classroom. So, but yes, I think it was the original homework that was supposed to be from Wednesday night.